ऑप्टिमाइजेशन टेक्निक की इस क्लास में आपका स्वागत है। हम सिंटैक्स मेथड की स्टडी कर रहे हैं और हम रैखिक प्रोग्रामिंग समस्या का मूलभूत बुनियाद देखते हैं। स्टेटमेंट है if a LPP makes set equals to Cx subject to X equals to B and no negative conditions such greater or equal to 0. This is standard form for syntax method which admits an optimal solution. Then at least one PFS must be obtained. कहना क्या चाह रहे हैं कि अगर इस सिंटैक्स मेथड से सॉल्व की जा सकने वाली LPP का ऑप्टिमल सॉल्यूशन विद्यमान है तो वह ऑप्टिमल सॉल्यूशन कम से कम एक PFS में से होगा। इसके प्रूफ के लिए हम दी गई समस्या में A कोएफिशिएंट मैट्रिक्स है। इस कोएफिशिएंट मैट्रिक्स से A जो कि m/n क्रम का है लिख सकते हैं हम अल्फा 1 अल्फा 2 अल्फा n और here अल्फा 1 अल्फा 2 अल्फा n are activity vectors। और चूंकि स्टेटमेंट में ये कहा गया है कि उसका एक स्तंभ विद्यमान है तो हम स्तंभ इसका x स्टार मानेंगे। So say x star is x1 x2 xn स्तंभ है इसका और ऑब्जेक्टिव फंक्शन हमारा z इक्वल्स टू cx मैक्सिमाइजेशन का है। सो z स्टार इस x स्टार सॉल्यूशन के कॉरस्पॉन्डिंग उद्देश्य प्रयोग का अधिकतम मान है बिकॉज इट इज ऑप्टिमल सॉल्यूशन। सो corresponding z star corresponding to this x star z star is x। अब ये जो n वेरिएबल्स हैं x1 x2 xn यहाँ पर इनमें से कुछ शून्य हो सकते हैं और मैं भी हूँ। कोई भी शून्य नहीं है तो नॉन जीरो वेरिएबल्स की संख्या n हो जाएगी। बट देयर में बी सम वेरिएबल्स आर जीरो। तो हम मान लेते हैं कि दी नंबर ऑफ दीज वेरिएबल्स के अक्षरों के मान नॉन जीरो के अक्षरों के मान नॉन जीरो मान नॉन जीरो। इट मीन्स remaining n minus k variables are zero. So these are n minus k variables which are zero and these k variables are non-zero in optimal solution। हाँ, ये अगर कोई भी जीरो नहीं है तो k का मान n है n वेरिएबल्स नॉन जीरो। और अगर उसमें शून्य है तो हम मान लेते हैं कि k वेरिएबल्स नॉन जीरो है, रिमेनिंग एलिमेंट्स की जीरो। In this case, because x star is the optimal solution, x star is the optimal solution. So by the definition of solution, what is the solution? Because x star is optimal solution, it means x star is solution. X star is solution, or by the definition of solution, it will satisfy the constants. So this is LPP, and this ax equals to b, ax equals to b is subject to condition. So since x star is the solution, it means x star satisfies this equation ax equals to b. So we can put x star in place of x. So we get ax star is b, and a is alpha 1, a is alpha 1, alpha 2, alpha n. So this ax is alpha 1 x1 plus alpha x2 plus alpha kx, and plus here plus alpha k plus 1 equals 1 x k plus, but up to xk these are non-zero. After this is xk plus 1, which is 0. So 0 and plus finally vectors are 0. So these are 0. So here there is 0. There will be so, and in summation form, this is alpha j x j is 1 to k equals to b. So this is the method to number alpha j x equals to b, and maximum z equals to c1 x2 plus c2 c a x k. After that, values are 0. So this is z equals to 1 to 3 6x. And now here number of vectors, activity vectors are k, alpha 1, alpha 2, alpha k. For these vectors, there are two cases arise: case first and case second. Case first, alpha 1, alpha 2, alpha k are Li. It means this solution x star, where these k vectors are non-zero, is Vx. If these vectors are Li, then this solution is these vectors are basic, and so this solution is a basic solution, also physical. But and it is Vx, and so our term second is Vx, which is so if Vx is talk about that. But if second case, alpha 1, alpha 2, alpha k vectors are linearly dependent, then this is not basic or basic solution. So since alpha 1 alpha 2 alpha k are linearly dependent, so there are scalars lambda 1 lambda 2 lambda k such that lambda alpha j equals to 0. LC of these vectors is 0 where at least one lambda j is non-zero. At least one lambda j is non-zero. Suppose this lambda j is non-zero, then there are also two cases arise. Either lambda j is less than 0 or lambda j is 0, or second case lambda j is greater than 0. So if lambda j is greater than 0, there is no problem. But if lambda j is less than 0, then multiply equation 3 by minus 1, and so lambda j is positive. So ultimately we found lambda j is positive, and then choose value v such that lambda j over xj is maximum. Such that lambda j over xj is maximum. Choose the value for j 1 to k. Then clearly xj is greater than xj. Why xj is greater than? Because xj j equals to 1 to k, all xj are non-zero. Here in this solution, x1, x2, xk are non-zero, and by non-negativity condition, each x1, x2, xk must be then equal to 0. But here this is non-zero, it means greater than 0. So each xj is greater than equal to greater than 0, and so v is with this value v is greater than, as lambda j is greater than 0. If lambda j is less than 0, then multiply this equation by minus 1, so lambda j is greater than 0. Ultimately lambda j is greater than xj is greater than 0. It means this ratio is positive, and so v is greater than 0. Now multiply the equation 3 by 1 upon v and subtract 1 this one. Then subtract multiply 3 by 1 over b and subtract from 1. Then right hand side of 3 is 0, so right hand side of result is b minus 0 means b, and b minus 0 means b, and this is from equation 1, and this is from equation 3, multiply by 1 upon b and subtract. So we have this equation 5. Suppose this vector quantity is xj dash. Suppose xj minus lambda j over b is xj dash, where j is 1 to k. So I becomes j equals to 1 to k xj dash alpha j equals to b, and so xj new solution h dash is here x1 dash, x2 dash, xk dash. and remaining are 0. So new solution x dash is put up value of option dash. This shows that this x dash is the solution of which satisfies ax equals to b, which means new solution of LPP, new solution of any solution. And in this new solution, there is at least one more zero than n minus 2. These are more than n minus 8 plus 1 zeros. So since b is the maximum lambda j over xj, it means b is greater than or equal to lambda j over xj for each j. This one, and which gives xj minus lambda j over b is greater than or equal to 0, which is xj dash. So each xj dash is greater than or equal to 0. It means this solution, this new solution is feasible because each xj dash is greater than or equal to 0. So this is feasible solution. Now we want to show that this solution is optimal. So j के कम से कम एक मान के लिए हम b इक्वल्स टू लैम्डा j और xj होगा, नो हो, एंड सो at least one xj equals to 0, and f इसमें x dash के करों में से एक का मान 0 है. यहाँ इनमें कम से कम एक का मान 0 होने पर इनकी संख्या एक 0 अधिक होगी, पहले वो मैंने यहाँ लिखा है. और सो जिसमें 0 तक करों संख्या 0 तक करों संख्या कम होगी, इनमें से एक 0 अधिक होगी, कम से कम 0 जरूर होगा. ये एच बेस समस्या का इस करना है. इसे सिद्ध करने के लिए हम उद्देश्य फलन z डैश प्लस टू सी एच डैश में ये वैल्यू एच डैश की पुट कर देते हैं. देन दिस बिकम्स सी जे एक्स जे माइनस सी जे लैम्डा जे ओवर बी, एंड फर्स्ट दिस इज z स्टार सी जे एक्स जे फ्रॉम इक्वेशन 2. Cj xj j equals to into k z star. This is from equation 2 z star and minus 1 over b some sigma j equals to 1 to k cj lambda j over v. Then this if this z dash is z star, this solution will be optimal if z dash is z star. It means this term should be 0. So j equal to 1 to k cj lambda j over v must be 0. How we can do that? If possible, let this cj lambda j is not equal to 0. Let this not equal to 0. This is lambda j. 1 over b. b is fixed quantity, positive. So this can be written as j equals to 1 to k cj xj equals to 0, and so we want to prove that this is 0. For this let this is not equal to 0. तो एक ऐसी वास्तविक संख्या थीटा विद्यमान होगी जिसके लिए मल्टीप्लाई दिस बाय थीटा इज देन 0 बन जाता है, एंड थीटा को लैम्डा जे के साथ स्विच करने पर और बोथ साइड एडिंग सी जे एक्स जे, एंड दिस इज सी जे एक्स जे प्लस थीटा लैम्डा जे सी जे कॉमन लेने पर is greater than j equals to 1 to k cj xj. And so equals to v, which show that this xj plus theta lambda j is the solution, which is feasible also. This is solution of ax equals to b, because this satisfies the equation ax equals to b. So this is xj plus theta lambda j is the new solution. And choose theta so that theta j plus xj plus theta lambda j is greater than 0. When we choose theta lies between maximum j minus xj over lambda j and minimum minus xj over lambda j, then this theta xj plus theta lambda j must be greater than or equal to 0. So this xj plus theta lambda j will be feasible also. So feasible solution. And this feasible solution पर क्या हो रहा है, z का मान z' से बड़ा हो रहा है, जो z स्टार जो कि ऑप्टिमल माना था हमने, उससे अधिक कोई और वैल्यू हो नहीं सकती, which is contrary to optimal solution x star. So our assumption that this is not equal to 0 is wrong. It means this it means this j equals to 1 to k cj lambda j is 0, and when this is 0, then in equation 8 we find that z dash equals to z star. ये जब 0 हो जाता है तो z dash equals to z star, but z star is the optimal solution. It means this z dash is also optimal solution. So corresponding to this xj minus lambda j over b, which is xj dash, is the optimal solution of the LPP. तो हमने देखा कि परिणाम आठ से z dash z star स्पेस 20 में सका इष्टतम होने हो गया है, और x dash में समीकरण सolution सदिश अब जब x dash में k x star में नॉन जीरो वेरिएबल्स थे, x dash में k माइनस 1 अधिकतम नॉन जीरो वेरिएबल्स हैं, और corresponding वेक्टर्स भी अल्फा 1 अल्फा 2 अल्फा k माइनस 1 जिनकी संख्या k माइनस 1 पहले से एक कम होगी. These vectors may be linearly independent, and then this solution is BFS. And if again in case second, if these k minus 1 vectors are linearly dependent, then repeat the above process so that we find k minus 2 non-zero variables, and on repeating this process ultimately हमें समस्या का एक BFS प्राप्त हो जाता है, जिस पर सेट करना इष्टतम होता है. तो हम उसमें ये बताना चाह रहे थे कि BFS कैसे विद्यमान होगा जो हमें ऑप्टिमल सॉल्यूशन देता है. किसी LPP अधिकतम करना के रिक्वेस्ट से सब्जेक्ट टू आई एक्स इक्वल्स टू बी नो नेगेटिव कंडीशन एक्स ग्रेटर देन और इक्वल टू 0 का इष्टतम हम विद्यमान है, तो कम से कम एक BFS इष्टतम होता है. ये हमने इस थ्योरम के माध्यम से प्रूव. अब हम इस बात के बाद थ्योरम के बाद एक एग्जाम्पल लेते हैं जिसमें एक फिजिबल सॉल्यूशन दिया है. x1 equals to 2, x2 equals to 4, x3 equals to 1. This is सिस्टम का फिजिबल सॉल्यूशन. इस फिजिबल सॉल्यूशन से हम BFS फाइंड करना चाहते हैं. So our problem is to find feasible solution to basic feasible solution. So we are going to discuss the method how we find a BFS from feasible solution. Suppose x1 is 2, x2 is 4, x3 is 1, no doubt this is feasible solution of these constants LPP. So in matrix form, first column is 2, 1, second column is minus 1, 0, third column is 2, 4, corresponding to variables x1, x2 and x3, and the requirement factor is 2, 12. In matrix form, suppose first is column is alpha 1, second column minus 1, 0 is alpha 2, third column is alpha 3. First column is alpha 1, second column is alpha 2, and third column is alpha 3. Activity vectors. Then we can write alpha 1 x1 plus alpha plus 2 plus alpha 3 is equals to b. This is equation 1 corresponding to equation 1 in form, fundamental form. See here, this is j alpha j plus equals to b. इस तरह से हम equation 1 प्राप्त हो जाती है ऑप्टिमल सॉल्यूशन से दिए गए solutions. And here alpha 1, alpha 2, alpha 3 and b are non-negative in this now, so satisfying. And this is fs. So this put x1 equals to 2, x2 equals to 4, x3 equals to 1 in this equation 1. So we get 2 alpha 1 plus 4 alpha 2 plus alpha 3 equals to b. And here for vectors are alpha 1, alpha 2, alpha 3, which are clearly linearly dependent. हम यहाँ इस फॉर्म में दो केस स्टडी करते हैं कि if vectors are linearly independent, then this solution is basic, and if linearly dependent, then हम इस क्रिया फॉलो करते हैं जिसमें v डिफाइन करते हैं maximum lambda j over j, and at least one lambda j is greater than 0. देखते हुए यहाँ पे क्वेश्चन नंबर 4 हम डिफाइन करेंगे. Value of v alpha 3 lambda 1 alpha 1 plus lambda 2 alpha 2 equals to alpha 3, and here alpha 3 is 2, 4, alpha 1 is 2, 1, and alpha 2 is minus 1, 0. So 2 here, which gives lambda 1 equals to 4. This is greater than 0. अगर minus 4 होता तो इस equation 3 को हम minus 1 से multiply करके निकलेंगे, but this 4 is greater than 0. So lambda 2 is 6. This is also greater than 0. में एक ही कम से कम एक ही 0 नोट पॉजिटिव चाहिए, कोई बात नहीं, 2 लेंगे हमारे पास दोनों नोट में 0 है. तो put the equation 3 becomes now lambda j alpha equals to 0, and where lambda 1 is 4, lambda 2 is 6, lambda 3 is minus 1. This is corresponding to equation 3 in our form, number form. See here, this is lambda j alpha equals to 3. Equation 3 we have already. Now find v equals to maximum lambda j over xj. So lambda j over xj, here j is 1, 2, 3, right? There are 3 variables, x1, x2 and x3. So maximum of lambda j over xj, j equals to 1, 2, 3, means lambda 1 over x1, second lambda 2 over x2, lambda 3 over x3. Put these values, then this is, the first is 2, second is less than 2, and this is negative. So maximum is 2. So value v is 2. This is key element. This is known to key element. So our key element is 2. Now new solution x dash is we do that in this form. New solution x j dash equals to x dash equals to xj minus lambda 0 b, where j is equal to k. So x new solution x dash is xj minus lambda 0 or v, where j equals to 1 to 3, and value of x is 2, lambda 1 is 4, or value v is 2. Put in this, we get 0, 1, 3 by 2. There is at least one more 0. So this is the basic solution. This is the basic solution. So we can, by this method, we can find feasible solution to basic feasible solution.